All right, welcome to Chapter 11, Section 5, called Tangents. This is for Integrated Math 2 or IM2. A couple of things you'll see on your screen here before we get started. You'll see a due date. I don't see it on my teacher preview, but you will see it on your student screen. We always have unlimited attempts for homework, tests, and quizzes. Number of questions just lets you know how many on this particular assignment. Grading policy is always best score, so whichever one is the best one is one to keep. Partial credit is enabled, so if you answer one or two questions correctly, you get credit for the one question. Or if there's multiple pieces within a question, so like multiple answers, you can get partial credit within one question. Please remember, once you start your homework, you must finish it before you can work on anything else. That means, once you click Start, down in the bottom right corner, you'll see a Submit Assignment button. I know it's not here for me, but it will be there for you on your student side. This is how you finish an assignment. And what it means when it says you can't work on anything else is literally the program is going to lock all of your other assignments and resources, everything, until you click Submit Assignment. It's attempting to leave this attempt open for you. It's trying to help you. Remember, we have unlimited attempts, so there's no reason to leave this attempt open. It will also save your place. So if you've answered a question, you click check, and you get a little green check mark, it will know that, and it will start you back up where you left off. It's not going to make you redo anything. So huge reason to click Submit Assignment is that so that it doesn't lock you out of everything in the system. The second big reason is it affects the gradebook. So you can see your progress in the gradebook, and your teacher can see your progress in the gradebook. So until you click that button, basically everything is frozen. So good idea, always click it. On the side here, sometimes we have calculator. That's not always open, just depends on what we're working on. But we always have explanation, example, and message center, sorry. Explanation tells you you're going to lose your current question attempt because it's going to give you the solution to this question. It's not going to give you the solution and then let you come type it in. Example will show you something very similar to what it is you're looking at, and it'll explain it to you. So with this one, it's having us go through, and it's giving us two tangents that are coming through. So a tangent, which I don't think is a term that we've actually gone over in my videos yet, that's when you have a line coming from outside of the circle, and it touches the circle in just one place, and it would continue on, you know, but it touches that circle in just one spot. That's what we call a tangent. So if we have two tangents of a circle or originating from the same point, they are congruent. So they're both coming from W and they touch the circle. This one touches at Y, this one touches at X. Well, these guys are congruent. So if one is 5.2, the other is 5.2. So that's what one of the key factors here with tangents. A tangent of a circle is also perpendicular to the radius drawn at the same point of tangency. So if I draw a radius over to that point of tangency, and I could do the same thing over here, they're perpendicular. So they create a little right triangle, don't they? So then they go through and start using Pythagorean theorem to fill in, you know, what is WO, the length here. We can use Pythagorean theorem and find the answer, the question they're asking us for, because in this case, they wanted to know what's the length of WO. So they already drew this one across this here, but we could also have done this one. It would have actually been the exact same thing, because if this radius is 3.9, so is this radius. So we're just kind of applying a few rules of tangents here. And down here we have Message Center. You can message your teacher directly from the screen, and it attaches a picture so we know where to come help you. All right, so let's go ahead and apply these properties of tangents. So we have, oops, I didn't mean to open the calculator. So we have circle O, and actually I'm just going to be a little bit lazy here. I don't want to have to draw this whole thing, so I'm going to just copy it and drag it on over here because that'll be a little easier, I think. Where is it? There it is. Okay, and we'll zoom in on this guy a little bit. Okay, so we have DF equals 4, and OD, so the whole thing, make sure it's not just that little piece there, but the whole thing is 5. Find OE. So they want this length here. So remember, if this is a tangent, and I'm going to color this a little bit differently. So here's my first tangent going from F to D, or D to F, originating from the same place is this other tangent. So this would also be 4. If they originate from the same place, they're both the same length. So now I have this length, and I have 5, and I'm missing this other piece here. Also remember, if it's a tangent, the radius drawn to the tangent is perpendicular. So this is a right triangle. So I can go a squared plus b squared equals c squared. That's our Pythagorean theorem. So I can go question mark squared, I know I'm being silly with a question mark, plus 4 squared equals 5 squared. If you've never seen anyone use anything other than letters as a variable, you can use anything that you want as a variable. It is literally just a placeholder. That's all a variable is. Now, I don't think Alex would ever accept question mark as a variable because it's not necessarily something that's widely accepted, but truly anything can be a variable. It's just a placeholder. That's all it is. And why not question mark? We don't know what it is. So I'm just being silly with my question mark there, but all right, so plus 16 equals 25. So I just squared these guys. We're going to subtract 16 from both sides. I think eraser is going to be, oh, it's not too big. All right, put my marker back on. Okay, so we have question mark dropping down. 16 minus 16 cancels. And 25 minus 16, well, that's going to get us 9. So the square root of both of these, well, that would be just question mark, right? Question mark times question mark. And the only number that multiplies by itself to get 9 would be 3. So OE must be 3. All right. The next one, so we're going to look at identifying chords, secants, and tangents of a circle. Oh, nope, sorry, skipped way too far ahead. This is just tangents of a circle, problem type 2. So I was actually reading something from the next section. I was going to say, wait, that's not what we're doing right now. So this is just problem type 2. It's the same type of idea. So I'm going to go ahead and copy this guy over here. I'll do it tall this time, so maybe that'll fit a little better. Don't save. Okay. And let's zoom out a little bit there. All right. So now they haven't labeled this one for us, so we get to label this one up a little bit more ourselves. So we have CF and CD are tangents. So CF and CD are tangents. And they're originating from the same point here. It goes all the way to F. So that's a little bit farther than we want to go. We actually want to go to E and D. Those would be the two tangents that are congruent when we're thinking of the tangents originating from the same place. We need to go from the point of tangency. And there's the center of the circle, which is O. We can see that. FD passes through the center, so we call this a diameter, but it, again, doesn't go all the way to D here. It would only go part of the way. So it would only go from the side of the circle over here. So there's this little piece that's left out of that measurement there for being the diameter. And we're given that CD, let me go back to my blue. So CD equals 6 and FD equals 3.2. So FD, the whole thing, equals 3.2. So that's a little bit, I guess I'll put it in pink. So FD, I'll go like that, all the way across equals 3.2. And they want us to find FE. We need to apply some of our rules that we already know. So this one looks a little bit different. We don't have that section coming down, in the middle and creating 2 right triangles. Instead, what we're going to do is create 1 right triangle. And this is a diameter going across, even though it doesn't go all the way. I know that goes a little farther, but this is the diameter, this red section, and it's at the point of tangency for this one. So this is a right angle. So we already have a right triangle. Oh my goodness. So we can do a squared plus b squared equals c squared. And the reason we're going to find this entire length here is because if this side equals 6, this other blue side equals 6, just for this section here, right? So if I know the whole thing, I can subtract to find that tiny little missing piece, which is the one they're asking me for. So I can just kind of do a little subtraction. I have to figure out the whole length, and then I can use segment addition to find the little piece that they're asking me to find. So let's go ahead and do our Pythagorean theorem. So we have a squared plus b squared equals, and I'm just going to go ahead and put c squared on there instead of using a question mark again. So I have 3.2, why didn't it go in? 3.2 squared plus 6 squared, which is 36, but I'm just going to type in 6 squared. So I'm going to go ahead and hit equals. So it's 46.24. That's c squared. So I need to take the square root of this. I need to come over here and hit square root and go like that. So it's 6.8 equals c. That's not my answer. That's the entire length. That's FC. That's the whole thing. Remember, I'm only looking for that tiny little piece there, FE, right? So what I want to do is take 6.8 and subtract the 6 from it so that what's left over, that's my length. So 6.8 minus 6 is just 0.8. So 0.8 is the length of FE. So we kind of had to go through, apply our tangency rules, and then make sure that we went back and actually paid attention what it was they were asking us for. Just kind of depends. I've seen them only ask for the whole length, and I've seen them ask like this one for the little length. So just make sure you're paying attention. That was section 5. I will see you in section 6.